Sorry. Hello, this is Tyler recording for 2012 question number 2. And this is asking if dx dt is square root t plus 2 over e to the t and dy dt is sine square over of t. What's gonna be the slope, what's gonna be x coordinate at certain time, what's gonna be the speed of the particle at certain time, and what is gonna be the distance traveled. So this is simply asking you if you know the concept of parametric equations, if you know how to get dy dx from dy dt and dx dt, and something like, and if you can just plug numbers into t or whatever other variable it is to get x or y at certain time. And this is given as a form of dx and dy. Therefore, you need to actually integrate if you wanna find anything. Find x or y at time t. So the question number A asks for dx dt at time equals 2. Because the question is essentially asking you if the particle is moving to the left or right. And at time 2, if it is moving to the right, dx dt is gonna be greater than 0. If it's moving to the left, dx dt is gonna be smaller than 0. If it's 0, there's no x movement in x-axis. So that's gonna be vertical line movement segment. Excuse me. And in this case, when you plug the number in to this function, you're gonna get 2 e to the 2 plus 2 over e to the 2, which is 2 over e to the 2, e to the second. I don't really care what specific number it is, and it's definitely greater than 0, because 2 is greater than 0 and e to the second is greater than 0. Excuse me. That part was easy. And question B is asking me to get an x coordinate at t equals 4. X coordinate means that I'm integrating dx dt to the respect of x t. That would be x of 4 equals 2 to the 4. It's actually from 0 to the 4, but I'm using 2 to the 4 because I know what we just got, the number, how it is in t equals 2. So I'm gonna plug numbers in. T plus 2 over e to the t, and I'm gonna add 0 to the 2. I'm doing this because, sorry about forgetting dt, never do that. I'm doing this because it's given that at time t equals 2, the particle is at position 1, 5, and this is x at t equals 2. This means that x has been traveled by 1, no matter how crazy it moved. It's 1. So we're gonna plug 1 into this right segment of this function. Therefore, I'm gonna get, by putting into calculator, 1 plus 0.252, which is equal to 1.0252. And C is even easier. It's asking me to get a speed at a certain time. We don't even have to, like, that is the formula we have been memorizing forever. Integral of, square root of dy dx dt squared plus dy dt squared equals this is just physical stuff that when things are moving into x direction and y direction, you just want to get the diagonal section right. This is happening, I think, because it's integrated stuff over d dt, but you don't really need to know that. You know x velocity, x speed, y speed. You just want to get the whole diagonal speed. When you just plug them in, the numbers at time equals 4. Numbers are, sorry, I'm coughing a lot. Square root 6 over a to the 4 plus sine squared 4 squared. And that's gonna get you 0.575. Oh no, oh dear. Come back. Go down. Please. Please, I'm trying so hard. Alright, I'm gonna pause. Sorry about it. Can't even pause. Alright, you're there. So I get 0.575 and oh, it also asks me to find the acceleration vector of the participle at time t equals 4. And that's even easier because we're just gonna okay, I totally forgot to do this when I was doing my problems. That and this is using quotient rule, which is pain in the ass because I need to get dy x prime prime or second derivative of x to the respect of t and second derivative of y to the respect of t. X part was especially tedious, but I did it. I used quotient rule and chain rule to pull things down. T plus 2 to the 1/2 is bringing t plus 2 to the -1/2 and 1/2 in front of n. One's gonna come out, which is the coefficient of t. And by plugging 4 in, you're gonna get negative 0.4, 0.98. Excuse me. And the last part, D, is asking me to get a distance traveled by the particle from time t equals 2 to 4. 2 to 4 is given. It's that easy. And distance travel is actually you are taking diagonal segment of total function and you're differentiating it over the segment right here. So the thing is gonna be dt, and inside of it it's gonna be square root of x dx dt squared plus dy dt squared. And by plugging things in, we have a value at t equals 2 and t equals 4. It's gonna get you 0.650. Thanks for watching. This was Tylee.